when I took my analysis course, you had to memorize all these definitions and spit them back out and then be able to use them as proofs. So that was just part of it. And some people like that, some people don't. Before you decide to stop your mathematical career, I just, again, want to encourage you that you stop your mathematics whenever you decide to, but once you stop, it's really hard to pick it back up. You know what I'm saying? So if you decide to stop taking math courses in college, make sure that you for sure want to be done. So I would encourage you there. Okay, so let f be continuous and differentiable over AB. Then there exists C in AB such that f prime of C is equal to f of B minus f of A over B minus A. Darren said something very intelligent earlier. He said, that looks like slope. What part looks like slope, Darren? F of B minus f of A over B minus A. Very good. And it is. Okay. Very good. So let's understand what this is talking about. If I were to draw a little graph, and I have, we'll call this value B, call this value A. So that'll make this f of A. That'll make this f of B. So Darren said that if you look at this, the average rate of change can be expressed by, the slope, f of B minus f of A over B minus A. What the mean value theorem basically says is there's a C value somewhere inside AB such that when I take the derivative of the function at that spot, its slope will match the slope of the mean value. So how would you describe the slope? Positive, negative? If you were to estimate it somewhere between 0 and 3, what would you estimate it to be? Okay, maybe about 1. So I need a volunteer. Somebody want to volunteer? Caleb, you tell me when I get to a spot on the graph of f such that if I drew a tangent line at that spot, the line would be parallel or have the same slope as that segment. You ready? Okay, so if we were to draw a parallel line there or a tangent line there, you can see that looks like it's parallel to the other, segment, right? So this would be a value C. I'll call it C sub 1. There's also another spot, isn't there? So in this case, there's two values that satisfy the mean value theorem. What do you think? Our goal today is to find the mean value of the rate of change, and then after that, we will set it equal to the derivative and find where these C spots are located. Okay? Ready to do that? Let's do it. Take out your calculator as well. I'm going to type in my function, which is x to the third minus 6x minus 1. I'm going to take this function, and I'm going to first, I'm going to find the critical points of this function. If you remember, we found the critical points by taking the derivative and setting it equal to 0. What's the derivative? If we factor out a 3, we get 3 times x squared minus 2. We have critical points of x is equal to plus or minus the root of 2. Do you remember yesterday how we found the local max and local min and absolute max and absolute min? We took the endpoints and we plugged them into the function. So f of negative 2, f of 3, and then we also plugged in the critical points, f of the root of 2 and f of negative root of 2. And this is not part of the mean value theorem, but it will help us sketch this graph and kind of generate some of the discussion we want to talk about. So I'm going to go to my table. I'm going to type in those values. Negative 2, 3, square root of 2, and negative root of 2. F of negative 2 is 3. F of 3 is 8. F of the root of 2 is negative 6.7. And negative root of 2 is negative 4.7. Positive 4.7. Okay. Now, I could get a pretty good sketch of this graph already. I have a coordinate of negative 2, 3. And that's an endpoint. I have a coordinate of 3, 8. I have a coordinate of negative 1.4, 4.7. And I have a coordinate of root of 2, negative 6.7. 1.4, negative 1, 2, 3, 4, 5, 6.7. And as I draw this curve, you can see I'm talking about this cubic function just over that given interval. Now it says, what is the average rate of change of the function over that given interval? Well, that's where I do f of b minus f of a over b minus a. What is f of b? 8. F of a, b is 3, a is negative 2. We get 5 over 5, which is 1. I'm going to draw a segment that represents that average rate of change. It simply connects the two endpoints. Does that segment look like it has a slope of 1? Yes. The mean value theorem says that there is at least one x value, they call it c, that sits between negative 2 and positive 3, such that when I take the derivative, I'll have a slope the same as 1. Do you agree that you can look at that and kind of see? Let's find those spots. It says find a point C in the interval that satisfies the mean value theorem. Well, I take f of b minus f of a over b minus a, which is 1, and I set it equal to f prime of c. Meaning we set it equal to the derivative and we find c. So 1 equals, what's the derivative? So I solve, and I get 7 is equal to 3x squared. So 7 over 3 is x squared. So the root of 7/3 plus or minus is x. Now, I'm not going to rationalize the denominator because I'm going to choose to express my solution as a decimal. But if we take the root of 7 divided by 3, you can see that you get 1.53. So x is 1.53 and negative 1.53. If I look at negative 1.53 and positive 1.53, wait a minute, whoop, gotta back that up. Does it seem like at those spots I might have a tangent line that has a slope of 1? Yeah, let's actually find the equations for the lines. Line 1, we're going to have you guys do line 1, and we'll do it when we get back. Go get some brain food. We'll see in a little bit. All right, we've got line 1. We've got line 2. You guys right here. You guys are going to find the equation for line 1. You guys right here. You're going to find the equation for line 2. In In order to find equation for a line, we need a point on a line, and we need our slope. Now, you guys right here are going to do the x value 1.53, and you guys over here are going to do the x value negative 1.53. What's obviously the slope for both of these? Yeah, it's 1. That's the mean value. We did our critical values, right? Or we found where x... We solved where the derivative was equal to the slope. Okay? Let's stop flipping, guys. Okay. What did you guys come up for the y value up here? Negative 6.6. So you got y is equal to 1x minus 8 point what? 13. So as we look at this, if I go y equals 1, 2, 3, 4, 5, 6, 7, 8. Is that right? 1, 2, 3, 4, 5, 6, 7, 8. Whoop. So I'm right there. If I draw it with a slope of 1, does it look like it touches tangent? Sure does. Now, if you do the next one, what do you guys get for y value here? Group 2. 4.59. And when you plug it in, you get y equals x what? Plus 6.12. So we go up 6, 1, 2, 3, 4, 5, 6. And a little bit higher, and you draw a line with a slope of 1. Does it look like it touches tangent? Sure does. So that's what we've just done. We verified that there are, in fact, in this case, 2 spots within that interval that work out. So flip it over. We are going to do 2 more examples for your notes, and then after that, we're going to let you work on your worksheet. We'll do examples 4 and 5 tomorrow, and we'll then give you the rest of the time to work. So we'd like to do exactly what we did on the front side, but in a little bit more condensed version. It says we'd like to use the mean value theorem to find equations for the lines tangent to the curve that have slopes equal to the average rated change of function over the interval. So we look at negative x squared minus 6x from negative 4 to 1. Sorry about the roster notation. Again, the mean value theorem says f of b minus f of a over b minus a is equal to f prime of c. So I first want to find f of b minus f of a over b minus a. If you like to, you can take out your calculator and you can use that to generate some points because I'm going to graph it anyway. I have negative x squared minus 6x. I go to my table and I type in 1 and negative 4. So I have negative 7 minus 8 over 1 minus negative 4, or negative 15 over 5. So I have negative 3. A is going to be the first value of your interval. B is going to be the end value of your interval. Okay. So that's my slope. How do I find the point at which it has that slope? Yes, it says I found this that's equal to the derivative at a given point. So I take the derivative, which is negative 2x minus 6 is going to be equal to negative 3. So a lot of times people are used to saying that equal to 0, but you're saying equal to the slope. So negative 2x is equal to 3, so x is equal to negative 3 halves. So we have a slope of negative 3, point on our line, negative 3 halves, or negative 1.5. We plug in negative 1.5. We get 6.75. So our equation for a line will be y minus 6.75 It's equal to your slope, negative 3 times x plus 1.5. Y is equal to negative 3x. I take negative 3 times 1.5. I add 6.75 to it. Get 2.25. I'm going to graph my new line. There's a way where you can actually show just a specific domain value. X test can go greater than, so 3, was it negative 4, comma, x less than, or 5, 1. See if it shows the actual, oh, it doesn't like that. I can't remember how to do the piecewise function thing. Instead of a comma, I need something else, but I don't know what it is. Oh well, I'll figure it out some other time. Oh, yeah, I don't know. Anyway, the point is this, is that what I want you to do is I want you to be able to sketch the graph. And so it looks like it goes from, my f of b value is a negative 7. My f of a value is an 8. It looks something like that. As you graphed it, the whole point is I just want you to be able to confirm your answer. And so you can see that I do have a tangent line. And if you look at kind of where you started and where you ended, your tangent line should have a slope that's equal to that of the average rate of change. Because I'm just going from negative 4 to 1. From value negative 4 to value positive 1. No, I'm not. No, I'm not that concerned about it. I want you to be able to think about it. As I look at this, the fact is, great, it's a tangent line. We've been able to do that all the time before. The fact is that if I trace this and I go to an x value of negative 4, I want to say, okay, that's one endpoint. If I go to x value of 1, that's another endpoint. And as you draw a segment connecting those two endpoints, it should be parallel to the tangent line. That's part of what you want to think about. That's the graphical representation of what we're doing. Just trying to connect the two together. See that? Okay, one last example. Okay. Again, f of b. So I'm going to take y equals, get rid of these two, and I'll type in 2 divided by, parentheses, x plus 3. And I'll go to my table. I'll type in 4 and negative 2. And I get those values. So I have 0.29 minus 2, 4 minus negative 2. 0.29 minus 2 divided by 6. So what is that? What did we find? Your slope. Yep, in order to find my point on my line, the x value I have to set equal to. Now, before you do this, just one small caution, okay? Is this continuous for all real numbers, or is it discontinuous? Negative 3. Is negative 3 in this interval? If it was, you would say the mean value theorem does not apply. Okay? Yep, you would say mean value theorem does not apply in this situation. But negative 3 does not fall in that interval. It's nice behaving during that interval, so we'll take the derivative. I'm going to write this as 2 times x plus 3 to the negative 1 power, and I'm going to use a chain rule. Okay, so I got 2u to the -1. I've got x plus 3. Derivative of x plus 3. Derivative of 2u to the -1. -2 over u squared. So I got -2 over x plus 3, that quantity squared, is equal to my slope, -0.29. How do I solve that? Cross multiply. -2 is equal to -0.29 times x plus 3, quantity squared. Now what? Divide both sides by -0.29, I get 6.9. 6.9 is equal to x plus 3, quantity squared. Square root both sides. How many solutions do I get when I square root? So I get plus or minus 6.9 is equal to x plus 3. Subtract the 3 over -3 plus or minus square root of 6.9 is equal to x. So that's going to generate two values for me. -3 plus square root of 6.9. I get -0.37. Is that in the interval? It is. Let's try the other one. -3 minus the square root of 6.9. And we get -5.6. Is that in the interval? No, so we don't need to do that one. We just need to do the -0.37. In order to generate the y value, we plug it back into the original function. -0.76. There we have it. So y minus 0.76 is equal to -0.29 times x plus 0.37. Oh, I had a negative in there I missed. Try it again. -0.29 times 0.37 plus 0.76. Okay, 0.65. So y equals -0.29x plus 0.65. As we sketch that graph, hopefully it will be tangent. And it looks like it is tangent. And even if we looked at the interval from -2, again, you can kind of see where your y value is. It kind of does one of those things, right? It starts there, and then as you go over to the end of your y value, which is, or end of your x value, so 4, so our interval ends at 4, and you can see it's it touches tangent. So I'm just verifying that it looks like it's going to have the same slope as the average rate of change. So it's just a quick sketch to show I verified it. So your worksheet, did I hand out your worksheet? Okay, so your worksheet, I'll hand it out. We'll talk about what problems you could probably get started with tonight. Okay, so for anybody that's watching, assignment, you could go ahead and do some of the worksheet, but we'll do the trig examples tomorrow and the radical examples. And I'll figure out how to type in piecewise functions to calculator as well.